Hello students, in this video we'll find the Weierstrass product for cosine and sinh using the Weierstrass product for sine. So let's recall, we have that the sine of pi z is equal to pi z times the product, n goes from 1 to infinity, of 1 minus z squared over n squared. This is the Weierstrass product for sine. Okay, excellent. We can use this to get other Weierstrass products for free, okay? That's the beautiful thing when you have absolute convergence, you can do ordinary product operations and get other ones for free. So now, let's do the following. So let's consider, recall, we know that 2 sine z cosine z is equal to the sine of 2z, okay? Great, and then therefore this implies what? So this implies that the cosine of pi z, for example, is going to be what? It's going to be just the sine of 2 pi z over 2 sine pi z. And now I can write down the quotient of these two things, right? So now write out the quotient. So what that tells us? That tells us the cosine of pi z is therefore what? Is therefore, well, what's the product for sine of pi 2z? It's going to be a 2 pi z times the product, n goes from 1 to infinity. I replace z, which is a 2z, right? So this is going to be a 1 minus, so 4z squared over n squared, divided by what? Divided by, then I have 2 times this thing over here, times 2 pi z, times the product, n goes from 1 to infinity, of 1 minus z squared over n squared, like that. Great. Yikes, that's a mess, right? The good thing is the 2 pi z's cancel out, right? And now what we're going to do is we're going to split this into even and odd roots. Okay? If we do that, what's going to happen over here? So we're going to have the product, n goes from 1 to infinity, 1 minus 4z squared over the evens. Now what are the evens going to be? The evens are going to be 2n, right? So I'm going to put it 2n squared, like that. Then what? Then I'm going to have times the product, n goes from 1 to infinity, of the odds, right? 1 minus 4z squared. And then what? Now I got to start with 1, so I need a 2n minus 1 squared, like that. Okay? Beautiful. All divided by the product, n goes from 1 to infinity, of 1 minus z squared over n squared, right? But now look, beautiful. This expression over here and this expression over here are the same. There's a 4 over here and a 4 over here. The 4's cancel and you have z squared over n squared. That cancels with that. And all that's left is just this expression over here. So we got our result. So that's our first result. Our first result is that the cosine of pi z, cosine of pi z, is therefore what? Is therefore the product, n goes from 1 to infinity, of what? Of 1 minus 4z squared over 2n minus 1 squared, like that. Beautiful. Now, sometimes I've seen it also written like this sometimes to just make sure that people don't get confused, right? 0 to infinity of 1 minus, I can just re-index this if I wanted to, like this, same thing. It just starts at 0 instead of 1 now, so it's giving me the same exact thing. Excellent, that's how you cosine pi z. Now, let's recall, what's the sinh of z? So recall, the sinh of z is e to the z minus e to the negative z over 2. So that says if I do a 1 over I sinh of iz, that becomes what? That becomes sine of z, right? Therefore, if I do what? I'm going to plug it in I now. So the sine of iz is therefore what? Is therefore the sinh of negative z. Okay, it's 1 over I the sinh of negative z, but the sinh is an odd function, right? So that becomes negative 1 over I sinh of z, but 1 over I is just I, so that's I sinh of z, okay? So that's a fundamental idea that the sine of iz is just I sinh of z. So we're going to use this methodology over here, that's our key, that's going to help us determine what the Weierstrass product for sinh is, right? So the Weierstrass product for sinh is going to be super simple to do, right? So what I'm going to do over here is I'm going to plug in, I want to know what the sinh of z is, right? What's the sinh of pi z? Well, the sinh of pi z is 1 over I, the sine of what? Of pi z, with an I. Okay? So that's what? That's 1 over I, and then I'm going to plug in, where am I going to do it? Everywhere I see a z, I'm going to replace it with an iz, okay? So I have a times pi iz times the product, n goes from 1 to infinity, of 1 minus iz squared over n squared, like that. Now those i's cancel out over here, so we're going to get our product. So the sinh of pi z is what? Is going to be a pi z, just like before, times the product, n goes from 1 to infinity, I squared is -1. That's going to turn into a plus. 1 plus z squared over n squared. Beautiful. And so we get this result. So that's the Weierstrass product for sinh. How do we get the Weierstrass product for cosh, right? We do the same thing. We know what? We can say cosh of pi z. I just plug in I, right? Because the cosh of z is the same as the cosine of I, right? So if I plug in I over here, this becomes the product. N goes from 1 to infinity of 1 plus 4z squared. Where is it? Yeah, 4z squared over 2n minus 1 squared. So I was able to get 3 other Weierstrass products just by manipulating the one for sine. Very, very cool, right? You can also do the same trick for Bessel functions. In further videos, we'll delve into Bessel functions and their Weierstrass factorization and how we can tie that in with some of the connections we made in differential equations. Thank you very much.